So next we're going to talk about surface area. So now we're looking at three-dimensional shapes, and we're going to do a couple calculations with three-dimensional shapes. The first is surface area. So this is saying find the surface area of the crate used for shipping. So when we say surface area, we're talking about the total area of all the sides. Okay, so if it's something that's a rectangular solid, like what's shown here, this would have 6 sides. So there's a few ways we can calculate this. First off, we could just find the area of each side. So like the front, let's say the front and the back are going to be the same. So for the front we'd have 6 feet times 3 feet, so that's 18 square feet. So that would just be for the front. So then we would double that. So that would be 36 for the front and the back. Now how about the top and the bottom? So the top and the bottom. So the top looks like it's 2.5 by 6. So 2.5 by 6. So I think that's going to be 15. And then double that, because that would be just the top. Double it to get the bottom as well. And then the sides would be, so this gray side looks like it's 3 by 2.5. So 3 by 2.5, it's going to be 7.5. With all these, I'm doing feet times feet. When I'm doubling it, it's still square feet. So then add them all together to get the total. And it looks like this is 81 square feet. Okay, now if we look at the formula sheet, so for a right prism, now we're using the word right prism here, and there's a box shape shown, 6 sides, but this could be applied to anything with a polygon, a side with a shape with sides. These formulas would apply to any shape. So it could be like triangular. We're going to do a hexagon in a minute. It would apply to any of those. So for total surface area, and then we'll go back up to what lateral is in a minute. Total surface area, what we have as a formula here is perimeter times height plus 2a. So this is looking at it a little differently than just adding everything up. So perimeter times height. So what we would do is perimeter is the perimeter of the base. Okay, so P, I'm going to kind of use some highlighting here. Perimeter of the base. So 6, 2.5, that back we can't really see, is another 6 and another 2.5. So the perimeter of the base would be 2 6s and 2 2.5s. So that's going to be 12 and 5 is 17. Okay, so 17 feet around. So if we take the perimeter and we multiply by the height, okay, so we're saying that our total surface area, I'm going to use TSA here, is 17 feet times the height of 3. So what that's going to do is it's going to get each of the 4 sides, 6 by 3, 2.5 by 3, another 2.5 by 3 on this side, another 6 by 3 on the back. So it kind of does all those 4 sides all together. Now it's saying plus 2a, so a would be the area of the base, so 6 times 2.5, because by doing perimeter, that basically multiplied each side by 3. Now here, 6 times 2.5, we'd done that earlier, that was 15. So there's 2 times 15, there's 30, same as how that was my top and bottom that we did before. So 51 and 30, 81 again. We get it the same way. So just a little different way of looking at it with the formulas. So we don't have to do it both of these ways, but that's just 2 different ways of looking at these. Now lateral surface area, and we'll talk about this more with the next one, that lateral is just the sides. Okay, so not the top and bottom. Not top and bottom. So in the case of this one, if I were to find the lateral surface area, it would have been the 51. The lateral on this one would have been just 51 square feet, not the 15 on the top and the bottom. Now going on to the next one, we have a cylinder here. So anything that has a circular base, but three-dimensional is called a cylinder. So this has an 18-inch diameter and 30-inch height. So let's talk about that lateral surface area somewhere here as we figure out how to get the surface area of this. So, and I've got an example of a can here. Okay, so it's got some printing on the sides. It's like some sparkling water from Target. So if the company had to figure out, well, how much aluminum do I need to make this can? And it's got some curves. It's probably a little more complicated, but to get kind of the basic idea, we'd be doing the surface area. That's going to be all the aluminum. But let's say too, they just want to figure out how much printing for the side. So that'd be a reason why we would need to know the lateral surface area, just the side. So, and this is sometimes called the wrap in manufacturing. So the side, so here's my can. So to figure out the area around this, if we think about it, I'm going to take a piece of paper and I'm going to wrap it around. Okay, so this piece of paper, by wrapping it around, this would be the outside. So notice though, it's really just a rectangle. Okay, and the top of it, we fold it again, the top is the circumference. So the top of this rectangle should be the circumference of the circle and then the height. Okay, so looking at the can, see how that piece of paper is wrapped around the can? It's the circumference on the top. Okay, so let's do that for this. So to get the circumference around, 2 times pi times radius, I'm going to use that version. So if it's an 18-inch diameter, 9-inch radius, so the circumference of the circle is 2 times pi times r, and then, so that is 56.55 if I go to the hundredths. Okay, so if I take that, that's the top of this rectangle if I flattened it, times 30. Okay, so the lateral surface area, I'm going to do LSA, or the wrap, is 1,696.46 square inches. Okay, so that would be that, again, just the outside. So that's called the lateral surface area. Now, we need to also find the area of the top and the bottom to get the total. Okay, so the area of the top, let's go, I'm going to go up here. Area, let's say the top and the bottom. To get the area, we're going to do pi r squared. So pi times 9 squared is 254.47. Now, that's just for one of the circles. So if we double that to get the top and the bottom, I'm at 508.94. 508.94. Ooh, there we go. So now if I combine to get my total surface area, add those together, the lateral, so the side and then the top and the bottom. $2,205.4 square inches. Now, if we compare that with the formula, so see right here, lateral surface area, the version that we did, so all these equal signs is just different versions. So circumference times height we talked about, we did 2 pi r and then we multiplied by the height. So that was to get the lateral, and then to get the total surface area, here it says capital S, I was doing TSA Either way though, either capital S for total surface area or TSA. So we had taken our lateral and we had added 2 times the area of the top. Okay, so A, area of the base. Now one more. I'll do one more. Lost my spot. So this one is a hexagon. Okay. Find the surface area of the following figure where A is 3.5. Okay, so the side of the hexagon is 3.5 inches. Height is 6.75. So this is actually kind of turned, but we really do need to picture it turn 90 degrees because the base needs to be whatever's the common shape that goes throughout. So as I go in one direction, it has the same shape. So really the base is a hexagon. So we have to kind of picture it turned. So to get let's get the area of each of the sides. So let's just get one of the sides for now. That'll be 3.5 times 6.75. Okay, so each of these would be 6.75 times 3.5. 23.625. Okay, so that's one of the sides. Now this is a hexagon. 1, 2, 3, 4, 5, 6 of these. So if I do times 6, all the sides is 141.75 square inches. Now, so that's my lateral surface area. That's my lateral. Now to get the area of the bases, okay, what I'm shading in right now, we need to know how to calculate the area of a hexagon. So this is actually, I don't believe this is on our formula sheet, but I have it here. It's 2.598 times A squared. Okay, so area of the hexagon base is 2.598 times A, so the side, 3.5 squared. 2.598 times 3.5 squared is 31.8255. That's for one of them, so we'll double that. 63.651. And this is all area, so still square inches. So to get the total surface area, I'm just going to do TSA. Add those two together, the bases and the sides. 205.4 about.